Now, as we learned back in Chapter 22, amino acids can also be drawn as Fisher projections, just like simple carbohydrates. You might remember from Chapter 22 that simple carbohydrates in nature all have the D configuration, that is, the configuration where the OH is pointing to the right in the Fisher projection. Oddly enough, the opposite is true for amino acids. That is, most amino acids found in nature have the L configuration, with the amino group pointing here to the left in the Fisher projection. You should also remember from Chapter 22 that there is no direct way to correlate L or D with R or S. The only thing that we can say is that if an L amino acid happens to be S, then its D isomer will be R, and vice versa. And just in case any of you appear in a trivia show later in life, you might want to know that all of the 19 L-amino acids that have stereocenters, glycine does not have a stereocenter, so it's not included. But those that do have stereocenters happen to have an S configuration, except for cysteine, which has an R configuration. If any of you guys want to know why, you can ask me in class. The author of our textbook claims that the easiest way to remember these 20 amino acid structures is to separate them into individual categories according to their properties. That might be true for some people and might be incorrect for others. I suppose that depends on the way that you personally happen to memorize things most easily. For me, I find that the easiest way for me to remember things is by creating my own vulgar limericks. Actually, I'm just kidding. I don't have one particular memorization technique that I use all the time for everything. But for me, I often happen to be able to remember concepts by making up my own crazy acronyms. For example, I can remember the name of all the amino acids that have nonpolar side chains, these ones shown on this slide, by remembering the acronym phrase, I lag at PP. Isoleucine, leucine, alanine, glycine, valine, methionine, phenylalanine, and proline. I lag at PP. Now, I understand this might sound borderline vulgar, but the fact is, vulgarity is usually really hard to forget. For remembering the amino acids with polar neutral side chains, those ones that are shown here, you might consider remembering the acronym phrase, thanks, that's yuck. Threonine, asparagine, tryptophan, serine, tyrosine, glutamine, and cysteine. For remembering the amino acids with polar acidic side chains, you might consider remembering the phrase, always good. Aspartic acid and glutamic acid. And for remembering the amino acids with polar basic side chains, I want you to remember the acronym HAL. He's one of my favorite characters from the show Malcolm in the Middle. Anyway, HAL stands for histidine, arginine, and lysine. Now, one thing I want to tell you with absolute invariable hesitation is that I am not going to quiz or test you on these acronyms. I really can't. They're just Mike's own dorky way of remembering the amino acids' names. You can come up with your own way of memorizing their structures and names if you wish. Also, I'm not going to require you in this class to even memorize the amino acids' names and structures. That will wait for our biochemistry class, which will happen in a later semester. Nevertheless, I do want you to at least have some exposure to their structures and names. And if my acronyms and phrases happen to help you, so be it. If not, then please forget them. Now to something else. You should know that amino acids can never exist as uncharged compounds. That is, you'll never see an amino acid existing in a neutral state, like the one shown right here. Why? Because a carboxylic acid is way more acidic than an NH3+. In other words, this hydrogen right here is way more acidic than these hydrogens right here. So if you wanted to have an amino acid exist in its neutral form that I've X'd out over here to the left, in order to get that, one of these hydrogens would have to be removed before this hydrogen was removed. And that's never ever going to happen. because these hydrogens over here on the nitrogen are way, way less acidic than the hydrogen over here. Hence, once again, amino acids will never exist in this neutral state. I just have to tell you that because that might come across as being a little frustrating for you when you continually see us abbreviating them with having charges here, either in one position or the other or both. Now, because of this fact, at neutral pH, around pH 7, amino acids look like the picture shown right here. Now, just so you know, compounds like this one, which have a negative charge on one atom and a positive charge on another atom, are called Zwitterions. Now, this word derives from a German term, Zwitter, which means hybrid or hermaphrodite. You know, I've got to tell you, I think I really don't use the word hermaphrodite frequently enough in my everyday speech.